Right now, while you're watching this, a spacecraft is staring at a frozen moon nearly 390 million miles away. And what it just found isn't supposed to be there. Not according to any model, not according to 40 years of assumptions about how ice, radiation, and the vacuum of space are supposed to behave. Something on the surface of Jupiter's moon Europa is chemically active in a way that should be impossible. And the scientists who discovered it aren't calling it interesting, they're calling it a problem. This is the story of what the James Webb Space Telescope found on Europa, why it stunned the scientists studying it, and why it may be the strongest clue we've ever found that a hidden ocean less than 20 miles beneath the ice could contain the ingredients for life. Stay with me, because by the end of this video, you'll never look at Jupiter's moons the same way again. Welcome to Farside, where we explore the deepest mysteries of space and the universe. If that's your kind of journey, subscribe now, because we're only getting started. Let's set the scene. Europa is one of Jupiter's 4 largest moons. It's slightly smaller than Earth's moon, and from a distance it looks almost ordinary. A smooth, bright ball of ice covered with long cracks and surprisingly few impact craters. But that smoothness tells an incredible story. A world with almost no craters is a world with a young surface. It means the landscape is constantly being renewed, erasing the scars left by asteroid impacts over millions of years. Ever since the 1990s, scientists have suspected that beneath Europa's frozen shell lies something extraordinary. A global ocean of liquid water. Not a lake, not a buried sea. An entire ocean that wraps around the moon. Unlike Earth's oceans, Europa's water isn't kept liquid by sunlight. It receives very little solar energy. Instead, the immense gravity of Jupiter constantly squeezes and stretches the moon, flexing its interior like a stress ball. That endless flexing creates heat through friction, keeping the hidden ocean from freezing solid. Researchers estimate that this underground ocean contains more liquid water than every ocean on Earth combined. For decades, it has remained hidden beneath roughly 10 to 15 miles of solid ice. Completely inaccessible, completely unreachable, completely unknown. Until the James Webb Space Telescope turned its powerful instruments toward Europa in 2022 and again in 2023. What it found wasn't expected. Here's the discovery that made scientists stop and pay attention. In a region called Terra Regio, a chaotic landscape of broken, jumbled ice that looks like a frozen lake shattered into thousands of pieces, Webb detected a strong signature of carbon dioxide, not spread evenly across the moon the way you'd expect if it had arrived from space. It was concentrated, localized, almost perfectly aligned with one of the youngest geological regions on Europa, where scientists already suspected fresh material could be reaching the surface from deep below. And that's where things become difficult to explain. Carbon dioxide shouldn't survive very long on Europa's surface. Jupiter bombards the moon with intense radiation, constantly breaking apart molecules. Over just a few thousand years, a blink of an eye in geological time, surface carbon dioxide should disappear. Yet Webb found a fresh, concentrated deposit, which leaves only 2 realistic possibilities. Either something placed it there recently, or something is still placing it there today. Scientists analyzing the results, published in Science in 2023, reached a conclusion that surprised even them. The carbon dioxide most likely didn't form on the surface at all. It almost certainly came from below, from Europa's hidden ocean. And that changes everything. Because it suggests Europa's icy shell isn't the perfectly sealed barrier scientists once imagined. Instead, material from the ocean appears to be finding pathways through miles of solid ice, reaching the surface where a telescope millions of miles away can detect its chemical signature. Take a moment to think about that. We are no longer talking about computer simulations or theoretical models. We're looking at a real chemical signal on the surface of another world, one that appears to have originated inside an ocean humanity has never seen, never sampled, and never touched. And carbon dioxide isn't just another molecule. Carbon forms the backbone of every known form of life on Earth. Every plant, every animal, every human being. Everything alive depends on carbon chemistry. Finding a concentrated source of carbon emerging from a hidden alien ocean isn't just an interesting observation. It's exactly the kind of discovery astrobiologists spend their entire careers hoping to witness. But here's where the story becomes even stranger. And this is the part that almost nobody outside the research community is talking about. James Webb wasn't the first instrument to suggest that Europa might be leaking material from its hidden ocean. Back in 2013 and several times over the following decade, the Hubble Space Telescope detected faint, inconsistent signs of water vapor erupting from Europa's surface. These possible geysers appeared to blast hundreds of kilometers into space. If they were real, they would provide a direct pathway from the hidden ocean beneath the ice to the vacuum above. There was just one problem. The detections were frustratingly inconsistent. Sometimes Hubble saw what looked like a massive plume. Months later, it would observe the exact same location and find absolutely nothing. For years, scientists debated whether Europa's plumes actually existed or whether the telescope was simply operating at the limits of its sensitivity, detecting signals that weren't really there. Now compare those observations with what James Webb discovered. A concentrated deposit of carbon dioxide sits almost exactly where scientists suspected some of those plumes originated. Two completely different telescopes using completely different instruments, making observations years apart. Yet both point toward the same region of Europa. Both suggest the same thing. Something beneath the ice is active, and somehow material from that hidden world is reaching the surface. NASA isn't waiting to find out who's right. Right now, Europa Clipper is on its way to Jupiter. Launched in October 2024, it's the largest spacecraft NASA has ever built for a planetary mission. Instead of flying directly to Jupiter, it's taking advantage of carefully planned gravity assists from Mars and Earth, using their gravity to slingshot itself deeper into the solar system. When Europa Clipper finally arrives in 2030, it won't land. It doesn't need to. Instead, it will perform nearly 50 close flybys of Europa, each one collecting new information about the moon's mysterious interior. Its instruments were designed specifically to answer the questions raised by discoveries like Webb's. An ice-penetrating radar will attempt to look directly through Europa's frozen shell. Powerful cameras will map the surface in extraordinary detail. Thermal instruments will search for warm regions where fresh material could be rising from below. And perhaps most importantly, Europa Clipper carries an incredibly sensitive mass spectrometer. If the spacecraft happens to fly through one of Europa's suspected plumes at exactly the right moment, it could directly analyze material that originated in the hidden ocean, without landing, without drilling through miles of ice, without ever touching the surface. That's the possibility that keeps planetary scientists awake at night, in the best possible way. For decades, science fiction imagined enormous drills melting through Europa's ice to reach the ocean beneath. But nature may have already solved the problem for us. If Europa is naturally venting ocean material into space, then all we have to do is fly through one of those plumes with the right instrument switched on. Sometimes the universe offers shortcuts, and Europa might be offering one right now. But there's another detail hidden inside the James Webb observations that deserves far more attention. Alongside the carbon dioxide, researchers also detected hints of additional compounds whose chemistry appears consistent with water interacting with a rocky seafloor. That may sound like a small detail. It isn't. Because on Earth, wherever water meets hot rock deep beneath the ocean floor, something remarkable happens. Hydrothermal vents form where superheated, mineral-rich water escapes through cracks in the seafloor. These places exist in complete darkness, far beyond the reach of sunlight. Yet they're bursting with life. Giant tube worms, blind shrimp, strange bacteria that don't rely on sunlight at all. Instead of photosynthesis, they survive using chemical energy released from the Earth's interior. Entire ecosystems flourish around these vents, proving that sunlight isn't the only energy source capable of supporting life. If Europa's hidden ocean has anything even remotely similar, and the chemistry cautiously suggests that it might, then this icy moon possesses one of the most compelling combinations astrobiologists could ever hope to find. Liquid water, a long-lasting source of energy. Organic carbon chemistry, all existing together beneath the same shell of ice, potentially for billions of years. That's an extraordinary possibility. But it's important to stay grounded in what the evidence actually says. No scientist studying these observations has claimed that life has been discovered on Europa. And anyone telling you otherwise is going far beyond the evidence. What the data does show is something much more subtle, and in many ways even more exciting. Every new mission, every new telescope, every new observation keeps adding another piece to the same puzzle. Instead of eliminating Europa as a possible home for life, each discovery strengthens the case that it remains one of the most promising places in our solar system to search for it. That's not how scientific hype works. That's how scientific evidence builds, slowly, carefully. One observation at a time. So where does that leave us today? Europa Clipper is still making its long journey toward Jupiter. James Webb continues to observe Europa whenever viewing conditions are favorable, searching for changes on the surface, monitoring the carbon dioxide deposits, and watching for fresh signs of plume activity. Every observation becomes another clue. Every clue helps reveal a little more about the mysterious ocean hidden beneath the ice. What began as a single, unexpected patch of carbon dioxide has become one of the strongest pieces of evidence yet that Europa is not a frozen, lifeless world. Instead, it appears to be a dynamic moon with an active ocean that has been running its own natural chemistry experiment for billions of years. We're still years away from definitive answers. But for the first time, we aren't relying only on theories. We're watching real signals from a real ocean on a real world. And we're asking a question that once belonged only to science fiction. What if we're not alone? Not somewhere across the galaxy, but right here inside our own solar system? What if the evidence has been sitting on the surface of Europa all along, simply waiting for a telescope powerful enough to reveal it? If you enjoyed this journey into one of the greatest mysteries of our solar system, make sure to subscribe to Farsight and turn on notifications so you never miss our next exploration into the unknown. Leave a comment below with what you think Europa Clipper will discover when it reaches Europa in 2030. And if someone you know loves space as much as you do, share this video with them. Until next time.